Do you want me to really say coming right up?
Yeah.
All right, we'll do that.
I want you to charge into this.
All right. Hey, coming right up, we're just back from Israel, New Orleans. We had a great show, and we unveiled our X-ray that now does aluminum alloys in 2 seconds instead of the 15 to 30 seconds that all the other analyzers do. We're going to tell you all about that.
Why are we here today, guys?
I'm here today. I'm Don Sackett, CEO, co-founder of Sciaps. I'm here with one of our senior product specialists, Colin. And today we're gonna talk to you about our really new, really fast aluminum sorting application on the X-ray. A lot of people have LIBS units out there. We're talking about LIBS for sorting X-ray. We've come up with a really fast, really precise way to use X-ray to sort aluminum alloys. And with this, you can sort just about every aluminum alloy in a 2-second test. When you think about that, especially in the recycling area, the recyclers love the X-ray guns. They've been using them for years. They trust them. They're fast. They're precise. They're great on stainless, on high temps, red metals, turnings. Historically, the weakness of X-ray has been on aluminum alloys. I was at a hands-on ISRI training session just last week at the end of ISRI, and that was all reinforced that a lot of these X-ray units, all of them in fact, take anywhere from 15 to 30 seconds or longer to analyze a lot of aluminum alloys. What we're going to show you today is our Turbo X and our aluminum app, which would do those aluminum alloys and more all in 2 seconds. So this is going to be anywhere from 10 to 15 times faster than traditional X-ray guns on aluminum. All right, so I'm here with Colin. Colin's our product specialist, as I said earlier. He's also our one-time supermodel, as you can see from one of our earlier brochures.
Yeah.
Here we go. Wow.
How am I looking?
We must have done a lot of photoshopping and airbrushing to get from this to that. Anyway, that's Colin. Nice sweater, by the way.
Thank you very much.
Yeah, food in New Orleans was good, huh? Okay, so let's start out with some good alloys. Here we go. So very common mix-up because of the speed issues. Let's do an 1100 first. So we'll put that there. I'll show you this, Colin. I'll hit the trigger. 2-second test, 1100. Key is no magnesium in that one. Now let's go to a 6063. 6063 is often mixed up with 1100 because it'll have up to a 0.1 copper, and the 1100 always has some copper. But it also has about 0.5% magnesium. So these other X-ray guns might take 30 seconds or longer to see the magnesium. And a lot of people don't want to stand and wait that long. Our new aluminum app, look at this. 2 seconds, you'll see that 0.5% magnesium, and you're done.
There you go.
There you go. You do it again. There you go. A little higher. This one's up around 0.65, 0.7. See, in 2 seconds, we're seeing that mag. We're seeing 6063. So with our Turbo X and our fast aluminum, you don't any longer have to worry about mixing up these two or giving up speed. Just for fun, here's a 6061. This is a little higher mag, a little copper. There you go. There's your 6061 all in 2 seconds. So that is working really fast. And any other X-ray gun is going to require anywhere from 15 to 30 seconds to do that separation. We just did it in 2. All right, let's do this. Here's another common mix-up. Here's our 2024. It shows up. High copper and also high magnesium, up around 1.5% or so. Often this will be mixed up with 2014. 2014 has much lower mag. Other X-ray guns, you got to test a lot longer. Again, we'll show that. We'll do that in 2 seconds. Here's your 2-second test, 2014. See, they only about 0.3, 0.4% magnesium. So that's a good sort too. Another one that you see, here's a very common 3003. Because of the 1% manganese, it's very easily identified by almost every X-ray gun. But a common mix-up is the 3005. This is almost the same alloy, except it's got 0.2, 0.3% magnesium. So again, the Turbo X here, we'll see that mag in the 2-second test. There it is. There's your low mag. You can scroll back. Just look at the difference. You got 0.3 or so mag there. And on an 05, you go back to your 003. You've got no mag, which is really the difference. No mag versus about 0.3, and that's really the way to sort a 3003, 3005.
And so that's the main difference between
A lot of
this and every other analyzer
That's
is that
right.
those first 2 seconds we're
That's
seeing
right.
that mag and it takes
That's
15 or more on another.
15, 30, some of the models even a minute. So we can do all these in 2 seconds now. So what we've basically done is taken away the one real disadvantage to X-ray has always been on aluminum alloys, speed-wise. So by offering a really fast magnesium and silicon measurement, mainly magnesium, we've eliminated that disadvantage. So finally, here's one of my favorites. These two alloys are inseparable by any other X-ray. One is a cast 356, one is a cast 357. They're identical, except 356 has magnesium down on the 0.2, 0.3 range, whereas 357 has up around 0.5, 0.6. So let's do the 357 first. 2 seconds, 357. There's your 0.5 or so mag. Right now, let's switch over to 356, which is about 0.3. Hit that. 2 seconds. There's your 356, about 0.25 mag. So really fast. Again, 2 seconds, you can sort all these aluminums now. So it really rivals the speed of LIBS these days. And again, the key to this thing is a couple of things. First of all, what we realized is to sort aluminum alloys well, you need you need a really good magnesium measurement, a good silicon measurement, along with some of the transition metals. What we did in the turbo unit, first of all, we went out and we have our proprietary X-ray tube that's a very high brightness tube. If you know X-ray tubes, in the low voltage setting it runs at about 500 microamps of current. That's anywhere from 2.5 to 5 times more X-rays than other brands. Secondly, we flipped the way we do the analysis. We hit the aluminum alloy with the low voltage, high brightness beam first, because we realized in the world of aluminum you can sort just about every aluminum alloy by doing that. And so the instrument will only go to the second beam for a few more seconds if it needs to measure alloying elements that are higher in the periodic table, like lead, bismuth, tin, zirconium. Those are some common ones. There can be others. So the way this works is you shoot it in 2 seconds. You'll almost probably 95, 98% of the time you'll ID the alloy as we just showed. If it is an aluminum alloy you need to measure zirconium or lead or tin, it will then automatically flip to the other beam setting, which is high voltage, low current, and take 2 more seconds and do that. So what that amounts to is 98% of your aluminum alloys you're going to sort in 2 seconds. The occasional one that requires these other elements, it's going to take 2 more seconds. So you're really looking at 4 seconds total, but 2 seconds for almost everything. So that's where you get that tremendous speed advantage. But like X-ray, you still have the big, all the benefits on stainless and high temps and red metals and everything else, turnings. So that's how it goes. So that's the story on the Turbo X and the aluminum app, now available. We had a very successful ISRI show last week in New Orleans, showing it to all the people that visited our booth. One thing worth mentioning with the LIBS is still, one of the questions we got a lot was, well, if your X-ray is so fast on aluminum, why do I need LIBS? And what we would tell visitors to our booth is really there's still 3 reasons you might want to consider LIBS. First reason is maybe you just don't want any X-ray sources on your facility. You don't want inspections, you don't want to wear badges, you don't want to deal with regulations. If that's the case, then LIBS is still a great technique, especially for aluminum alloys. There are some elements you just can't measure with X-ray, and only LIBS can measure those in a handheld form factor. For example, lithium and aluminum alloys, beryllium, boron, carbon. Those are the key ones, especially for metals. We had a couple of consumers come by our booth at ISRI wanting to measure low boron in their aluminum alloys, down under 30 ppm and higher, which the LIBS can do, and which X-ray can't. So there's specialty things like that LIBS is really still geared for. And then finally, if you get a lot of scrap that has an anodizing on it, what's nice about the libs, it'll burn through that coating, so you don't have to grind it to get a good analysis. If I take an anodized piece of aluminum like this one, and I shoot it with my X-ray, you see I just get a crazy result. It says, high sulfur, high silicon. I don't get a good grade match. The quality of the match is well below our typical cutoff.
Okay.
If I take the libs and shoot this anodized piece,
Goes right through that.
goes right through it. See, I get a great,
You don't have the
Great
sulfur
match.
messing up, whatever.
right, no sulfur. It's a perfect match just to 60, 63. If we can put that out there. So that's a good shot. So if you get a lot of anodizing, you don't want to grind. Libs is an answer for that. But if you're doing a lot of just general aluminum scrap, and you've used X-ray and you're satisfied with it, you just wish it was 10 to 15 times faster. Now we have the Turbo X with the aluminum app, and that's really the solution. So finally, we've got this X-ray analyzer that does really everything well across the board, now including aluminum alloys.